All right, welcome, ladies and gentlemen. My name is Brian McLogan, and I am on week 17 of Open Q&A. I think I've gone 17 weeks in a row, kind of. I know I've missed a week here or there, and maybe it hasn't been completely 17 weeks, but at least the tracking I'm doing, we're going to work with 17 weeks of Open Q&A. So I wanted to thank all of you that have been joining me. If this is your first live stream, welcome. But I also know there's some students that have joined on multiple live streams and submitted their questions, and that is the purpose of this live stream, is really just to kind of do an open Q&A where you guys submit questions and I will try to answer them. I was kind of worried at the beginning of the year being able to not stay consistent with my live stream calendar. So therefore, I would just let you know that I will, make a announcement here or there. But I feel pretty comfortable so far. Through these 17 weeks, we've been pretty consistent with Sunday night at 9 p.m. Eastern Standard Time. So I'm going to commit to that. And what I'm going to do is I'm going to start making these announcements on my community tab a little bit earlier. So therefore, more of you have time to submit your questions and I can answer them because I made the announcement on the community tab this morning and, I had some questions, probably maybe like 4 or 5 on that community tab. And then what I did is I went back to the older community post that I did and I found some other questions. And so I ended up being able to knock out a lot of extra questions that people had previously asked that I wasn't able to add onto other streams, because they asked those questions after my live stream was over with. So hopefully if I can make some announcements earlier, that will allow people to get their questions done and prepared in time. And then obviously it's going to hopefully try to avoid I don't want to go live and then people asking questions and then never get their questions answered. But I am not a genius. So just because you ask me a question does not mean it's going to show up on the live stream. There's a lot of things that I can cover and work through, but I want to make sure that I can give you guys a good explanation, and I don't want to spend too much time thinking through a problem or have to kind of look at different ways to explain something and waste everybody's time, and especially sometimes get caught or get stuck on a live stream and then have to come back. And I've had to do that a couple times, like please text me or email me, and therefore I can respond back to you with the actual answer, now that I'm not having everybody watch me do my math work. So anyway, we have 9 questions for this live stream, and once I'm done with those, we'll kind of see how the time goes, and hopefully I won't ramble at the beginning for too long, so therefore we can get to these. And if you guys do have some questions, feel free to add them in there. I try to do my best, guys, of going back to these questions, but obviously there's, as people kind of get into these live streams and you guys are helping each other out, it does get a little bit hard to be able to include everybody's question. I will say just spamming the chat is not a way to be able to get your question answered. So, if I continue seeing that, I'm just going to have to breeze past your question because nobody wants to see spammy questions in the live chat. All right, so we're going to cover solving a logarithmic equations, solving a graph, a compound inequality, finding the range of a quadratic equation, multiplying polynomials. This student just kind of asked me to talk about the asymptotes for rational functions, basically to be able to understand how to graph them, or how to graph a rational function. This question was basically understanding, what is a radian as well as the central angle for s equals r times theta. We have write the equation through the point 4, 0 with the slope equaling -1/3. How to find the zeros for plus or minus -1 given a polynomial. Really, the student wanted to do long division, so I'm just kind of doing a random problem. But if these are not zeros, then we're just going to practice long division because I had to make up the problem because they didn't give me anything. And then here's another problem where actually they gave to me. So before we get started, I would like to welcome David, Aaron, Michael, Truxton, Free Mail, and Sharit, Nameless, Toby. Good to see you guys on there. Jason, Michael, TNS Lover 92. Thank you, Dylan, Jody, Ashlyn, very great to see you guys all on the live stream. And T-Sol, Stan, Dylan, Jesus, Abe. Abe asks, is this Algebra 1? It can be. Basically, this year I cover teaching pre-calculus, but in the high school level, I've taught everything from Algebra 1 to AP Calculus. So, however, I haven't taught calculus in the last couple of years, so that's why I just kind of avoid a lot of the questions for calculus on the live streams, just because I like to be on point with my explanations. And, when you've been away from teaching something, especially on calculus, which is, a lot more in detail, I always like to make sure just my explanations are going to be refined. But most of the other stuff, I cover in my pre-calculus so often that everything I remember. But a lot of the stuff, sometimes like from algebra, for geometry, I don't remember a lot of the formulas and all that kind of stuff. It gets a little crazy. But all right, so let's go ahead and get started on this, and then I will try to do my best to feedback to the chat. I wanted to do this one last live stream because I know some of you do have exams coming up this week. I am giving my actual exams for my class this week. So if you have already taken your exam, awesome. Congratulations. Hopefully you did great. And if not, don't worry. It's only an exam. Your life is going to be much larger than just one exam. But anyways, that doesn't mean for the rest of you to still work hard, try to do the best you can do. And that's all you can do, is just keep on working hard and do the best you can do. But I will be taking a 2-week break since I'll be off teaching. So I will take a 2-week break, at least from doing the live streams. I still have a ton of videos that I've recorded that I haven't uploaded. So I'll still be shooting some videos on my YouTube channel. But as far as the live streams go, I will take a break, and then we'll go ahead and resume this back into the new year. All right. Enough for chitter chat, 10 minutes. I think that's enough. So let's get in through the solving. So 4 cosine squared of x minus 3x squared minus 1. The best way I like to understand these questions, guys, is just to look at this as a quadratic. So 4x squared minus 3x minus 1. So if I gave you this equation, right? Pretend like, forget about the cosines. Let's just deal with x. I could look at this and say, well, if this was 4, or I'm sorry, let's see, how could we factor this? The first two terms need to multiply to give me a 4x. So I have a couple options here, right? I could do a 2x and a 2x, or I could do a 4x and a 4x and a 1. And I see that 3 is a middle term, so I'm thinking initially that this is going to be factorable with a 4. So therefore, I'm thinking this is going to be a minus 1, and that's going to be a plus 1. So again, 4 times x is 4x squared. 1 times negative 1 is negative 1. And that gives you a positive x, and that gives you negative 4x. So very good. So that is the factored form when it was an x, right? But again, just let x equal cosine of x. So if you understand it from that regard, or if just say x equals cosine of x, therefore I could factor this to 4 cosine of x plus 1 times cosine of x minus 1 equals 0, okay? Now, as far as, yeah, there you go. Okay, so now I can go ahead and apply the zero product property. So 4 cosine of x plus 1 equals 0, and cosine of x equals positive 1. Now remember, cosine of x equals negative 1/4 here, and cosine of x equals 1. Okay, so remember when we're using the inverse cosine function, right, that restriction is only between 0 and pi. So if cosine of x is equal to negative 1/4, that is not going to fall within our, no, actually we can have that negative 1/2, negative 1/4, but never mind, that's not going to work. That's not what I was thinking of. I was thinking of when it's larger than 1. But either way, I'm going to need to use a calculator for this, and I'm not going to be able to look at that. I guess I'll be able to, I guess I do have a calculator, so let's put this in radian mode. Yeah, because I can do cosine inverse of negative 0.25, and that's going to be 1.8. Right, so that's going to be second quadrant. So if cosine's negative, that means it's going to be some angle that's going to be in the second quadrant. Now, the student didn't ask, yeah, it's between 0 and 2 pi. So x is going to equal, I'll round this to the nearest tenth. So that's going to be x equals 1.8. That'd be radians. And then cosine of x equals 1, well, that's going to be the angle 0, right? Because you can see here, 1 comma 0, cosine of x, so therefore x is going to equal 0. And again, these are the angles, right? X represents the solutions or the angles that are going to make this equation true. And again, I am rounding that to the nearest tenth in this case. Sorry, just had to check my live strat real quick. Okay. So yeah, the one thing you just want to be careful of sometimes when we do these factoring, if it doesn't become an angle on the unit circle, sometimes it is going to be something that you would not be able to find the cosine inverse. But again, if you have a calculator, then you could obviously, that would give you like no solution there and you'd be good. But in this case, we can figure out the cosine of x equals negative 1/4, but we'd have to use a calculator because we're not aware of that angle on the unit circle. All right, so for the next one, the student asked me to do something on long division. And I basically just wanted to make up an answer. And typically in my class, when we're doing long division, we're finding zeros of polynomials. We're not just doing division to do division like we did in Algebra 2. So I'm just going to kind of work through a typical problem. And I hope that these are zeros. Otherwise, I'm just going to kind of change the name of the problem. But if these are zeros, then we can write them as factors. So that'd be x plus 1 times x minus 1. And then we can multiply them to give us another factor of x squared minus 1. Now, the reason why you could do synthetic division in this problem, and again, whenever you're doing synthetic division, you have to have linear factors, which in this case we do, but we have to do synthetic division twice. So a lot of times it's better what I students is if you have a quadratic factor, is just to go ahead and use long division. So in this case, I have x squared minus 1. And therefore, you're going to take your polynomial, and we're going to write it under here. Okay, and now we're going to go ahead and do our long division algorithm. So long division algorithm basically says is take this first term, x squared, and you're going to divide it into the first term of your dividend. So x squared divides into x to the fourth. If that is confusing, I always told my students to write it to the side. How many times does x squared divide into x to the fourth? Well, that is x squared times x squared, and then you're going to multiply this times both terms. So x squared times x squared is x to the fourth. X squared times negative 1 is a negative x squared. Well, I don't want to put that under an x cubed because those aren't like terms, right? So I'm going to put it under this x squared. Then we're going to group the first two terms and subtract them. So I have nothing to subtract a negative 3x squared from. You could use a placeholder of a 0x cubed if you like. But now let's go and subtract the rows. Again, if you're doing this correctly, your first two terms are always going to subtract to 0. But then I have a negative 3x minus 0, negative 3x cubed, minus 0. That's going to give you a positive 2x squared. And then you could subtract everything if you want to. Again, you could just write this as a 0x plus 0. And therefore, you'd have everything down. A lot of times, just to save ourselves the time and the space, we don't bring everything down. We just kind of leave it until we need it. So now x squared divides into a negative 3x cubed. Again, write this to the side. Negative 3x cubed divided by x squared. Well, that's going to be a negative 3x. And now I'm going to multiply that times both of those terms. So negative 3x times x squared is a negative 3x cubed, which is the same. And negative 3x times negative 1 is going to be a positive 3x. So again, I'm going to write those down, group and subtract. Here, I'm not going to write my placeholders. So therefore, negative 3x cubed minus a negative 3x squared, that's going to go to 0. Then here, I can just bring this down to a 2x squared. That's going to go to 0. And then I'll have a minus 2. X squared divided into 2x squared. Positive 2 times 2x squared. And then 2 times negative 1 is a negative 2. And you subtract, and I did do my work right. And therefore, you have a remainder of 0. So, and again, the important thing in the concept in what we're talking about, if these are factors based on the zeros, well, since x squared minus 1 divides into this, x squared minus 3x plus 2 times, then that is also a factor. 3x plus 2. And I could factor that down one more time to give me a x minus 2 times a x minus 1. So therefore, we could say the linear factorization, something that we would do in this class, we would say is going to be x minus 2 times x minus 1, which occurs twice, so it has a multiplicity of 2, times an x plus, that looks really bad, times an x plus 1. So the student asked me to do something on long division, but so there's the work on long division, but I just want to kind of add in something from polynomials that we do, at least in the pre-calculus curriculum. All right, the next question says, write the equation of the line through the point 4, 0 with a slope of negative 1/3. I think it's important to understand that the point can be understood as a x and a y coordinate. And also that any line can, as long as you have a point and a slope, you can write the equation of the line using what we call the point slope form. So y minus y1 equals m times x minus x1. So that's what we call the point slope form. Now, it gets a little confusing a lot of times, like why are we calling this y1 and this one y? Why are we calling this one x1 and this one x? Well, again, like slope-intercept form is y equals mx plus b, right? So we only have one y and one x. So in reality, it's probably better to represent this coordinate point as x1, y1. Because remember, there's infinite many points that lie in this line, right? So there could be x2, y2, x3, y3. Like there's infinite number of points. So let's let 4, 0 be represented as x1, y1, whereas the y and the x, kind of like for slope-intercept form, just represent any point that we have, right? So if we're given 1 point, we'll call those x1, y1. But for any point that lies on the line, which is infinite many, we're just going to use y and x. Now, we also already have the slope, which is m. And so our goal in this equation, I'm assuming the student wanted us to write the equation in slope-intercept form. Because in reality, all we simply need to do to write the equation of line is just plug in the information. And then now we've written an equation of a line. However, if we want to write this in slope-intercept form, then y minus 0 is y equals negative 1/3 x minus 4. And now we can distribute this. And that'd be a plus a 4/3. Now it is in slope-intercept form where you can see the slope is still negative 1/3 and the y-intercept is going to be a 4/3. So I didn't get that from them on their question, but typically that is, what we need to do for that equation. All right. For the next question is kind of just like that basic understanding of a rating and a degree, as well as the equation s equals r times theta. And the really only kind of topic I just wanted to kind of cover with this is, one thing is we understand that halfway around circle is 180 degrees. And we know all the way around a circle, like when you rotate halfway around a circle, like that's a straight line, we recognize that to be 180 degrees of rotation. And when we rotate all the way around a circle, basically going a full revolution, that's 360 degrees, right? So from our geometry class, like we take the straight angle is 180, and then the full circle is 360. And then so when I talk about radians, basically the way that I explain radians to my students is I said, well, radians is basically kind of using the idea of our radius. Let's just use blue here. And saying, all right, here is r. And what if we took r and wrapped it around the circle? Yeah. So if we took r and wrapped it around the circle, what we would have is, like if we rotated it, like this r wrapped around the circle, from here to here would be the measurement of 1 radian. From there to there would be the measurement of 2 radians. And then from here to here, that rotation would be a measurement of 3 radians. So if we were to rotate all the way halfway around a circle, we could say it's going to be 3 plus a little sliver, which ends up giving us pi. Whereas all the way around the circle is going to give us 2 pi. Okay, so that's basically what, pi is. It's the number of radiuses that it takes to wrap around the circle. Now, again, that kind of comes into our next play is, well, what about when the, radius is kind of like different? So when we look at, like, let's pretend the radius here is 1, all right? And So the radius is 1 here, and let's just do 1 radian. So again, what S represents is this actual distance. So remember, an angle is representing a rotation, is a measurement of the rotation. So we're actually measuring these arrows of rotation. Whereas S represents here this actual distance that you would have to travel from here to here along that circle. So if my radius is 1 and my radian, the degree of rotation is 1, then you can see S is going to be r times, theta. Like, so S equals 1 times 1. And what the important thing that happens here is, what about when I get to, like a radius of 2? And my circles are getting really bad. But again, what you can see here is now my radius is from here is 2, but the angle does not change, right? The measurement from here to here is still 1. So what happens is, how does the S change then? Like, how does that measurement of S change? Well, all happens with S is now equal to a radius of 2 times 1. So S is now equal to twice that size. So when you're doing the S equals R times theta, that central angle, the main important thing is to make sure you understand that R needs to represent as a radian. So I probably should use some different colors, but sorry, hopefully that helps at least explain some of those ideas. All right, so as far as graphing rational functions, my best advice is, yes, make sure you know how to identify the vertical, the horizontal, the slant asymptotes, and how to identify the x and the y intercepts. I do not have time to give an example of all 3 of those, but what I will do is kind of give you an example of the vertical, horizontal, and slant asymptotes, and then what to do for the x and the y. So there's basically 3 examples, or 3 types of problems we have. Let's just say we have y equals, x squared plus ... over x cubed plus ... So again, whenever the degree in the numerator is smaller than the degree in the denominator, then the horizontal asymptote is y is equal to 0. Okay? The next example is, what about when the degrees are the same? For instance, 2x squared plus ... over 3x squared plus ... Now notice I'm doing the plus ... because we don't really it doesn't really matter what the rest of it is. When we're trying to identify the horizontal asymptotes, we just care about the comparison of the degrees in the numerator and the denominator. So when the degree in the numerator and denominator is the same, then the horizontal asymptote is the leading coefficient over the leading coefficient. So y equals 2/3. And then in this case, when we have y is equal to, let's say, x squared plus ... over a, let's say, a 3x plus ... Again, notice that the degree in the denominator is smaller than the degree in the numerator, so there is no horizontal asymptote, but unless there is a hole, you want to make sure you can check for a slant asymptote. So typically there's going to be a slant asymptote, but not always. You want to make sure you can check for that. All right, so how do we identify the vertical asymptotes? Well, the vertical asymptotes is when the denominator is equal to 0. But again, just be careful not to use holes, right? Remember, holes are going to be terms that are going to be divided out. So make sure that you do not include the holes there. To find the x-intercepts is when y is equal to 0. Okay, so y is equal to 0, and the quick little tip that I showed my students is just take the numerator equal to 0 and then solve. So it's always when y is equal to 0, but if you just set the numerator equal to 0 and solve, that will give you the x-intercepts. And the y-intercepts is when x is equal to 0, but for rational functions, that's really just going to be y equals the constant over the constant. So my handwriting is getting really bad, but if you really just look at a rational function at the end and just take the constant over constant, you can go ahead and find the y-intercepts. All right, so let's go and take a quick little break here. I see some of those questions coming in, and thank you so much, guys, for putting them. entering them in, there's no way I'm going to be able to get to these. And again, if you add your question more than once, I am definitely not going to be able to get to them. I do apologize, guys. I know a lot of you are adding into the stream and you maybe weren't on YouTube earlier and you really want me to get to your question, but I am just not going to be able to get to them. And I also don't want people to see your question more than once. So please just write a question and I will try to do it to my best. Obviously, if you see a question and you're able to help somebody out, I really do appreciate you being able to get to everybody and help them with their questions, or at least maybe lead them in a direction. Maybe I have a video that helps them or a playlist. Maybe there's somebody else on YouTube that has a video or a playlist that you can lead them in the right direction. Or maybe just have some other website, where else. But, please don't keep on trying to just shove your problem in front, because I'm pretty much limited here. I have 10 questions that I'm going to be covering. So for the rest of the live stream here, just for those of you that have kind of joined on to the end, I have this multiplying by polynomials. I have a range of a quadratic. I'm going to do a compound inequality, and then I'm going to solve a logarithmic equation. And then that's really, guys, all the ones. I maybe will add a 10, depending on how many of you are staying to the end. But I'm already kind of at my limit here, so I only have about 10 minutes left that I want to work through. So I also just want to let you guys know that I will continue be going live here on every Sunday at 9 o'clock East time, except for the rest of this year, because I'm going to take the next 2 weeks off as far as doing my live streams. But after that, beginning of next year, I will continue doing that. So Gabriel, that's not very nice, but I can see your messages. Nobody else can, but come on now. Adeline, yes, I never lived in Greek. Haas, distribute, and you'll get, thank you very much for helping some people out. This is so nice of you guys. I really do appreciate, because I know a lot of you guys, you come into live stream, you need help, you're answering questions. I know how frustrating math can be. And sometimes it's just those simple little things that you just need to get straightened out. You cannot understand why something is what it is, or what you're doing wrong, or what you don't understand. And, usually just somebody else looking at a different perspective can be like, oh, and then it's like, oh, now I get it. And it's such a frustrating part of mathematics. But I think is one of those beautiful things about mathematics that you build upon and you get better and better at it. And it's really only one of those things that, like, actually going through that process, that thinking process, is one of those ways that you do get better at it. So, all right, let's Gabriel. It doesn't your your message is not getting shown, but I can still see it. Okay. Thank you, Gabriel. All right, here we go. So next one is multiplying by a trinomial times a trinomial. You could use distributive property, but I think once you guys start using distributive property, you can see that this starts to look pretty crazy. So my preferred method is to understand that a product times a product is giving you an area. So what I'm just going to do is I'm going to create a nice little rectangle. And since these polynomials have 3 terms, I'm just going to break them up into 3 columns and 3 rows. And I'm going to take one polynomial and I'm going to place it along the top. I'm going to take the next polynomial and place it along the side. And now you can see that I basically have a rectangle that I'm going to try to find the area. So when I multiply length times width, I'm going to get the area. But rather than trying to find this area of this large box, I'm just going to do the length and width of each of these smaller rectangles and then combine them to give my final answer. So as long as you have everything in standard form, you can see how this box method is actually going to be really nice. So x squared times x squared is x to the 4th. X squared times negative 2x is a negative 2x cubed. X squared times 1 is a positive x squared. X squared, again, I'm just doing, width times length. Negative 2x times x squared is a negative 2x cubed. Negative 2x times negative 2x is just going to be a positive 4x squared. Negative 2x times 1 is a negative 2x. This gives you a negative 3x squared. Let's see, that's going to give you a positive 6x. And that gives you a negative 3. All right, so as long as I did my math right and I had everything in standard form, you can see how the diagonals are like terms. And this just makes our life so much easier compared to trying to do this, distributive property here. So my final answer is going to be x to the fourth. Let's see, negative 2x squared, those are negative 2's. Negative 2x cubed plus negative 2x cubed is going to be a negative 4x cubed. Let's see, that's going to give you a 5, negative 3, so that's going to be a positive 2x squared. This will give you a positive 4x, and then minus 3. So typically, whenever I'm doing anything with a trinomial, like multiplying, I like to use the box method. It just helps me rearrange things. All right, so to find the range f of x. So there's a couple things that I know off the bat for this problem. The first thing is I know that the parent graph looks like this, and that this graph is again going to be the same as a is positive, so it's going to be going up. So therefore, I think the student also asked like how to find the absolute minimum or extrema, the maximum or the minimum. We can tell that this graph is going to have a minimum. It's going to have an absolute minimum. I just need to figure out what that is. So there's a couple different ways we can do this. In my class, what we would work on is completing the square, writing this in vertex form. And basically, vertex form is going to be a times x minus h squared plus k, where the vertex is going to be your extrema, which would be hk. So to do that, what I'm going to do is I'm going to need to complete the square. So to complete the square, I'm going to need to write this as a perfect square trinomial. Now, I covered this a lot in my class. So the quick way, or at least this is the basic way to be able to do this, is going to take opposite of b, which is negative 4, divided by 2, and square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So by f of x equals x squared minus 4x. Now I'm going to add a 4. Now again, guys, you just can't like randomly add a 4 to an equation because now the equation is not the same, right? So if I'm going to add a 4, I'm going to need to subtract a 4. But the important thing is by adding this 4, what I did is I created a perfect square trinomial that can be factored into a binomial squared. So now I have f of x equals x minus 2 quantity squared minus 4. Whereas the vertex now is 2, negative 4. So I can see that the graph's being shifted 2 units to the right and 4 units down. So when I want to find the range, I would say my range is going to be from negative 4 to infinity. Okay, now another way that you could use to find that is to find the vertex. And if you remember, the vertex is going to be opposite of b divided by 2 times a, comma, f of opposite of b divided by 2 times a. And remember that opposite of b divided by 2 times a is your axis of symmetry. Basically, it's telling you, like, remember the vertex or extrema is gonna meet in the axis of symmetry. So if I took negative 4 divided by 2, or opposite of b divided by 2, that's 2 times a, which is 1. Yeah, okay. So negative 4 divided by 2 times 1, right? So that'd be negative 2, or 2. And then you plug negative 2 in, or you plug positive 2 in, sorry. And therefore you give me 4, negative 8, that'd give you negative 4. So yeah, that works out the exact same way. All right, last 2 questions on here. Ah, jeez. All right, so when we have a compound inequality, so basically the saying is, find the values of x and graph their solution that is going to be greater than or equal to 1, but less than or equal to 4. So you can even think of them like on a number line, like what would be the solutions that would kind of, make this equation true. But basically, this is what we call an and inequality. So whenever you have this compound inequality, we have 1 has to be less than or equal to 3x minus 5, and 3x minus 5 has to be less than or equal to 4. So now, all I'm basically going to do is just use my inverse operations to solve. So I'm going to add a 5. I have 6 is less than or equal to 3x, divide by 3, divide by 3. 2 is less than or equal to x. And a lot of times it's a little bit easier to rather write it like this, just to say x has to be greater than or equal to 2. Then this one, I'm going to add a 5. 3x is less than or equal to 9. Divide by 3, divide by 3, x is less than or equal to 3. So now let's go to our number line. Okay, so we have x is greater than or equal to 2, so let's put 2 here and let's put 3 here, right? There's no integer in between them. So let's just go x has to be greater than or equal to 2. Well, here's greater than or equal to. Oh, wait. Was that supposed to be? I meant for that to be less than. Let's just change the answer or change the problem. There we go. Now let's just forget that was there. So remember, when it's less than or equal to, that's what we're going to call a closed circle. So all values that are greater than or equal to 2 is going to be values to the right. But when I have x is less than 3, 3 is not included. Like 3 is not less than 3. So I'm going to use an open circle. And this is saying all x values that are less than 3. Well, that's going to be all the values to the left. Now, this compound inequality, again, is this and. That means that they both have to be true, right? So you can see that the only portion where both these equations are true is from 2 to 3, including 2, but not including 3. So the answer is going to be from 2 to 3. And sometimes, just write it like that, and there'd be your answer from there. All right, last one is a logarithmic equation to go ahead and solve. So there's a couple different ways to solve logarithmic equations. Basically, when you have logarithms on both sides, you're either going to want to be looking into, using the rules of logarithms, or converting to an exponential equation. And, some of them are going to use a calculator, some you're not. In this equation, I immediately see the one-to-one property. And hopefully you've covered the one-to-one property for exponents, because it's fairly basic for exponents. Like if I had, 2 to the x equals 2 to the third power, you could say, well, this makes sense. Like if 2 raised to what number is equal to 2 raised to the third power? Well, x is just going to equal 3, right? So when I have exponential equations with the same base raised to different powers and we want one variable, like we know those powers have to be the same. So that's the same thing with logarithms. Without going into the relationship of exponential equations and logarithms, I can just say, like, when I have a logarithm equal to a logarithm, and again, this only works when you have a logarithm equal to a logarithm, just like when we have an exponential equation equal to an exponent equal to an exponent with the same base. So these logarithms both have the same base because the base is e. So therefore, I can just rewrite the equation of 3/5 x plus 8 equals 1 minus x. So now I just need to go ahead and solve for x. So I'm going to add an x to both sides. So therefore it would be 3/5 x plus 8 equals 1. And then I'll subtract the 8. Now again, if I was going to rewrite, now again, remember this x has a coefficient of 1. So I can rewrite this as a 3/5 x plus a 5/5 x equals a 1 minus 8, which is a negative 7. Now 3/5 plus 5/5 is 8/5. X equals a negative 7. And then you just multiply by the reciprocal, which is 5/8. 5/8. So therefore x is going to equal a negative 35 over 8. Now again, remember the domain of logarithmic equations is restricted, right? So if you have a logarithm graph, that looks like that. So we're going to want to make sure we plug this equation back into both of our equations and just make sure that it is not going to make our equation less than 0. Therefore, it would be extraneous. Well, obviously, if I had 1 minus a negative 35, then that would be that is going to be positive. And then when I multiply by 3/5 from this negative 35/5, that's going to be smaller than 8. So when I add 8, it's going to make it positive. So therefore, I'm working, and that is going to be my solution. So there you go, ladies and gentlemen. That is going to be it. 9:42. Let's see. Maybe there's one more good question I could maybe add to this. Well, Snake Spencer, you helped me pass college, Trig. Thank you very much. You are very, very welcome. I'm so happy, and I do always like to hear the stories of how some of my videos, especially like the ones that are really old, that are really embarrassing, from when I had no idea what I was doing or planning to do in recording myself. But so if you ever want to kind of see some good chuckle, go back to 2010, 2011 videos. Kind of crazy. But yeah, so I'm glad to see that some of my videos have helped you out, but definitely cheers to you. The white cycle says finding missing angles with sine, cosine, and tangent. You're going to need to use your inverse trig functions, and either with a calculator or using the restrictions and the unit circle would be my best bet. Can you explain asymptotes? I can, but something with a little more specificity would be a little bit more helpful so I can make sure that I'm explaining them in best for you. Well, also, I'm very happy to help. My questions from 2016. Oh, no, come on. Ashlyn, you're giving me a conic section. How can you find the center and the radius of the circle? All right. If you give a function, how do you find its inverse? You swap the x and the y, and then you solve for y. So that is a very basic definition here, but I can do that. All right, Ashlyn, you asked the question. I'm going to get to you just because you gave me a direct question that I can answer. So I'm going to try to do this as best I can. All right, guys, I do not have any more time to go through on the questions. Are you sure that everyone that isn't good with math can be? Yes, because I don't really believe there's anything such that is really makes sense as far as you're not good at math. I just don't really follow that premise. I believe that a lot of people that struggle with mathematics, obviously there is some natural things, right, that people are going to be better at, some math or some analytic, thinking than others. But I also think a lot of people that, I think a lot of the experiences and a lot of the teaching from the very beginning of mathematics and the way that we still currently teach mathematics doesn't work for every student. And I think I think one of the big things, and I'm sorry, you really touched on a pressing point for me. But I believe that, like, we judge everybody in my class. Like I was telling one of my students the other day, I have to give a grade at the end of the quarter, but not everybody's ready for that grade at the end of the quarter. And I think that's a sad part of the way, our education is, set up nowadays. People say they struggle with math, but maybe they need a little bit more time. Maybe they just need it to be explained in a different way. Maybe they just need a better foundation than what other students had. So I don't blame it on that it's the math. I don't think it's the math at all. I think, math is natural in our lives and we can all learn mathematics. But if we're all going to try to compare, everybody needs to learn mathematics at the same time, to the same degree, at the same moment, I think that's just kind of ludicrous. So I don't follow the premise that people are good at math and not be good at math. I do believe that everybody can learn math. It really just takes the idea of understanding what needs to happen for them to be successful and giving them the time. I always tell students all the time, take your time. Even, some students fail my class. And I say, just because you failed my class doesn't mean you could not be successful in this class. Later on, you can take this class again later and do very well. You have that potential and you can put your work into it. And sometimes that's all it is. Sometimes just students need, to build up those foundational skills. How they learned, isn't supporting them to, be successful at math at that moment. Or sometimes they just need more time to think through things. Like, I have to give a grade at the end of this week. Like, there's nothing else I can do. I have to put in grades on Friday, but some people aren't ready. Some people are going to be taking their tests and they're going to need more time. But that's just kind of one of those unfortunate things. So, anyways, thank you for that question. I do appreciate it, but yeah, I don't buy the practice that people are just not good at math, so therefore they shouldn't try and they should just accept that and do something else. I don't think that is beneficial for anybody to accept that as a premise. All right, well, let me go and do this quick question here for Ashlyn. This is going to be a complete in the square problem, and I'm sorry, for sake of time, I'm not going to explain this as in-depthly as I typically will when we do conic sections. But the main thing is, to write the equation of the circle, we need to have it in this form. X minus h squared plus y minus k squared equals r squared. So we need to write binomial squareds. And like I explained up in this problem, we need to complete the square. That means we need to find the value that creates a perfect square trinomial. Because when we have a perfect square trinomial, we can factor it down into a binomial squared. So how do you create perfect square trinomials? You take the middle term, or your linear coefficient, you divide it by 2, and you square it. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. And I apologize if you're typing in any other questions for me. I'm not going to be able to get to them, guys. I do appreciate you adding on, but this is going to be my last question. Not only for this live stream, not only for tonight, but of 2019. Whoa, that's kind of crazy. 10 divided by 2 is 5. 5 squared is 25. All right, so I'm going to add these numbers on there. I'm going to put them inside parentheses. Plus y squared plus 10y plus 25. I'm going to put that in parentheses. I have now just created perfect choice trinomials. But again, guys, we just can't like add a number to the left side and not add it to the right side, right? If you're going to add a 4 to the left side, you have to add a 4 to the right side, right? So it's either you add and subtract them on the same side, add 4, subtract 4, or if you're dealing like an equation in counting sections in this case, if you're going to add a 4 to the left, you can add it to the right. If you're going to add a 25 to the left, you can add a 25 to the right. All right, so now this is going to give me x minus 2 squared is your binomial squared. And this would be a y plus 5 quantity squared. And this gives you a 29. So therefore, the center is going to be 2, negative 5. And the radius is, again, remember, this is r squared, right? So the radius is square root of 29. All right, guys, 10 questions. I love it. Thank you so much for those of you guys that have joined the whole stream. Yes, absolutely. Liking, adding the, smashing the like button is always appreciated. But thank you so much, guys, for holding on with me. I do wish you guys luck that still have your finals. My students could also use some luck for you guys as well because they're taking their finals this week. Actually, tomorrow it gets all started. And yeah, it's a tough thing. I know there's a lot that you guys have going on. You know, you guys have tests and you have quizzing, you have all these other classes and so many things. But if you guys are on the same schedule that I am on, you hopefully will get a little break and you can have some of that time to recharge and be with your family and get a little bit mentally prepared because we still have a half of the year to go. And I wish you guys all the best. Again, thank you so much for joining me guys on the stream. And I look forward to seeing you guys into the new year and getting these live streams going back on then. All right. Have a good night, guys. Cheers.